I think that's a good lead into the clustering discussion.
Oops.
Yeah,
I'm getting ahead of my slides.
we'll just do that.
So, if you look at, left-hand scale out, we could scale, so each time you added a node to the system, you added, roughly, 1,000 to 2,000 IOPS in performance, right? So then, 40 node system would get you up in the 50 to 60,000 IOP range, right? And, we're talking racks and racks of gear. Now our little 3U has 10x the performance of 2 racks of left-hand in a 3U box. So you have to ask yourself, well, why do you need scale out then? If you can get all the performance, in a small package, and then add capacity behind that package. With our dedupe technology, we actually have more capacity than a 40 node left-hand system in a 3U. So, so you ask yourself, well then, what's the requirement for scale? Well, you certainly want to scale out, but scaling out like we did at left-hand with Ethernet connections between nodes, that adds too much latency. You need to run at microsecond latency between nodes. If you've got solid state, you have to have a microsecond latency or nanosecond latency interconnect. Well, PCIe gives you that. So Kelly's point is, you want to scale your solid state out over a very low latency interconnect. You can scale your disk out with a higher latency interconnect, but it's all about, being tightly coupled versus loosely coupled. If you're solid state scale out, you really need to be a tightly coupled architecture on a very fast bus, PCIe, InfiniBand, whatever it might be, 40 gigabit Ethernet even. But if you're, and then your disk can scale at a much more slower, high latency interconnect. So anyway, the vision is, tightly coupled architecture for in the data center to scale your storage, and then outside the data center, to be over standard Ethernet, so site to site, synchronous replication between sites, asynchronous replication between remote sites, but in the data center, very tightly coupled. And so the scale paradigm changes quite dramatically. And if you can do tens of millions of IOPS in a couple of, 6U, then, and 4 or 5 compute domains, then this idea of having hundreds of compute domains, to service the I/O, only gets into the very extreme use cases of HPC and massive multi-tenant cloud. We're selling the mid-range storage market today, so actually, looking at that, our little 3U system with some PCIe scale out, some JBOD expansion addresses that entire market from a performance capacity standpoint. Once you go beyond that, then you get into a different market.
Okay, so all sorts of questions. I assume you're talking about Gemini pair type scale out, not the individual node scale out that you guys did with left-hand.
Yeah, it would be, it's a different model.
Yeah, because I always had problems with,
Yeah.
with the fact that to get controller redundancy, I needed to have twice as much capacity.
Right, storage
In that
and
model.
controllers
Yeah,
went
that was
together.
all about striping your data over as many spindles you possibly can to get your performance up, right?
Right.
Now, with hundreds of thousands of IOPS off of a single
Yeah, you don't
device,
need to do that.
you don't need to do that.
Okay.
And so for us inside a data center, it's not, you're not scaling capacity and compute at the same time inside a data center. You go remote data centers, that's a different story, right?
Right.
You want the data over there, you want the redundancy.
Right, but we're going to hit some practical limits of scale up.
Yep.
Yeah.
And that's
that
kind of what John was saying.
Redesigning the hardware to allow you to have 1,000 back-end spindles for capacity and 27 PCI slots in each controller for solid state makes a lot less sense than clustering a bunch of controller pair devices together.
Right.
We've just learned some of these lessons, I hope. And I don't know if I was tied up with something else or if you guys didn't go into it, but we haven't talked about the data reduction model in detail, have we?
No, not yet.
Okay, that's coming?
Yeah, we definitely can bring that up as a topic. Let's get through this and then we'll hit on that. How about that?
Okie dokie.
So just to emphasize what these guys were talking about. Today we do solid state on the PCIe bus, and then we allow you to scale capacity via SAS on the backplane. That's because you don't need low latency interconnect. But where we see this model going is being able to expand, a single compute domain via PCIe, out across.
Yeah, and the practical limit on that is probably about 16 controllers,
Yep.
which is a considerable amount of performance and capacity.
Right.
And there again, you look at that, that's kind of today's technology. Who's to say what we can do in 5
Right,
years?
right,
Yeah, and
right.
it's,
That's
And it may not be PCIe, it might be something different.
Well, it's
probably
gonna be
won't.
Thunderbolt, right? And just plug
You
it
got
into
it,
the.
see? You're getting it.
But
'Cause
Thunderbolt.
we don't care.
But Thunderbolt is PCIe.
yeah, exactly. I mean,
Thunderbolt is
the-
PCIe.
that's a good thing
repackaged.
to mention. The whole industry's moving toward, everybody realizes that SAS, SAT, and fiber channel drive type technology is not the right interconnect for solid state. So there's these new standards out there, NVMe, right, backed by, most of the big storage guys, and then there's also SCSI Express. All those
Just
are,
because HP felt that they
Yeah,
had to charge
exactly.
something.
but it's all PCIe, right? It's all PCIe interconnect.
Yeah.
Because the big guys said, yeah, solid state's bottleneck, current technology, let's do a PCIe standard interconnect. So you're gonna see this huge transformation of back ends. They just got done redoing their whole back end for SAS. Now they gotta redo it all again. But of course, they'll say plugging solid state into drive slots is still the way to go up until the time they've re-architected everything. It's kind of like, fiber channels, the best back end, you don't really need SAS, and meanwhile they're re-architecting their whole back end for SAS. They say, oh, okay, we lied to you, now SAS is the greatest thing, right? So
I remember being told that, in order to make fiber channel run on the front end, you had to run fiber channel on the back end. That really worked for me.
There's,
Those stuff adapters, what's that?
standards are not like Highlander, there can't be only one.
It's the
No.
thing about standards, there's so many to choose from.
But
See, because other
clearly,
standard, we should make a standard and unify all the standards together. And
Then it
then
won't interoperate with the other five.
Then you end up with one ring to rule them all.
pretty soon the elves are waging war on us.
Yeah.
It's really just best if we don't do that.
but the good news is our architecture is PCIe. You pull the drawers out, plug cards in, put the drawers back in. The model in the future may be a drive-looking array of PCI backplane and a drive array, right? But we're PCIe today, we're PCIe tomorrow when those standards finally hit.
So Kelly, why don't you walk them through some of the data reduction stuff and how that works in our system?
Sure. And are there any other questions before we jump into that kind of relative to what we've talked about so far? Okay. So one of the other things we baked into the system from day one is our data reduction technologies. We are a primary storage system, so data reduction is deduplication from most perspectives. Ours is a little bit different the way we do it. It's all driven by our QS engine. QS is core to the system. So for us, data reduction is multi-phased. There are some things we can do in the front end to use our current product above the solid state usage to dedupe data and reduce the data so we may not even have to take a write to the solid state. There's some amount we can do up there that adds very little latency or no latency to the system.
Wait, in the QoS?
The QS engine is control of all of this. So look at an I/O stack is the best way to look at it, right?
Are you talking about reducing data before it hits the solid state?
Yes. And reducing it later. It's a multi-phase system for data reduction.
Oh, my brain. Okay.
Yeah.
Well,
I
you
know.
really want to do that. You want to.
Oh, I agree.
You
But I
wanna-
mean, how big's the cache?
The cache has to be 2 to 3 times the throughput of the system times the latency of the data reduction engine. So,
So the effective size is like, I mean, I don't know.
a gigabyte or so.
Of
Yeah.
Before it hits the SSD?
Yeah. So
Okay.
somewhere,
It didn't
somewhere
sound like you were storing that much before you acted, but okay.
Yeah, they're actually, our system's capable, it's four 10 gigabit links on the front. So we can see 40 gigabit per second coming at us. So there's a decent amount of data in flight inside us.
And you probably want to allow on the order of 100 microseconds for for first pass data reduction time.
So let
So-
me kind of walk through a little bit of the top module that actually is a performed solid state.
Okay.
So it's geared towards and included in with the QoS. We can skip it. If QoS says, hey, we're already running behind, we're just going to get it down. We're not going to take the latency at all. It's just going to. But what it's designed to do is run at CPU speeds, CPU and memory speeds. So if you look at it from that perspective, it's a store from our store perspective, and it's operated within the CPU and the memory only. And we can actually provide calculations that will calculate the data for you. We'll update our metadata accordingly on write. A write's a really good example. Write's coming in, if we determine we can calculate it within our latency of the QoS engine, we'll calculate it, figure out if that's correct. We'll store the metadata that'll give us the ability to regenerate the data later. Read comes back down into that same data. We'll actually fire up the CPU engine, pop it into memory, feed it back out. No I/O is actually done to a persistent storage at that point because we're calculating. So that's our first level of deduplication that occurs. Does that kind of make sense then?
Yeah.
Why we do it and where we do it?
Yeah.
Okay. So that's the first one. Underneath that is where it's why we call it phase data reduction too, right? Underneath that's more of what you'd consider the traditional deduplication, where we have random data we can't predict, we can't calculate. A video stream is a really good example, an MPEG. I'm not going to be able to calculate the bits for an MPEG, but I can actually have the standard deduplication concepts of look it up in a dictionary, is that it, feed the data up. And that's back into where we have some section of memory dedicated to holding these patterns. We'll update our metadata on a write again. Here comes the data flowing in, we compare it against our dictionary. QoS drives it all. There's only going to be one dictionary entry at this level. We'll only have one possible to compare against. I'm not the most perfect deduplication engine in the world. My goal is to be a primary storage system that reduces the data, right? I'm not going to say, hey, I've got petabytes on me, and there is not a single duplicate block. It's not my system. My system is I am a primary storage system. QoS drives the show. I need to get your answer back to you fast.
And you only do the deduplication if the QoS says you have time.
You got it,
Exactly.
right?
Okay.
Right.
That's
So the second stage of our data reduction is more of a traditional deduplication where we're actually taking more random data. This data that's in here is limited in size, and it's actually allowed for only one to be in there. So we've got a quick key, quick hash into the dictionary. Dictionary is limited in size, do your comparison. It's a true or false, move on down the stack. Not going to compare it to everything. Now after that, we kind of land into solid state. Solid state's the persistence for that. That data is landed in solid state, it's persisted, it wasn't able to be deduplicated by the early phases. Cool, that's all good. Some point in time later, this data needs to move through the system. We use our CRCs as indications of possible candidates that are duplicate. So now we'll actually take the ability to, this data's moving, is its candidate, its possible sibling available to us to deduplicate within our quality of service timeframes? Can we deduplicate it going to SAS? So if two of them landed in solid state and we're moving them down for some reason, we can actually pull them both up, compare them at that point, store one, update the metadata, throw this away. So it's a multi-phased data reduction. Some terms are much similar to deduplication that's kind of standard in the industry. All driven by our QoS. We are primary storage. Latency is key for us. Latency and predictable performance. I am not 100% dedupe. I won't guarantee every block's deduplicated.
And you use the CRC as a candidate check.
Yeah, we actually have a couple of things we use as candidate checks. Fast, quick hits to say yes or no.
It's already indexed.
Yeah.
And then we do a full diff before we actually do
Oh,
the
yeah.
dedupe.
Yeah, we don't just say, hey, same CRC.
Yeah, that's good.
Yeah.
Maybe that's for the best.
Not quite as good as a shell and hash.
Yeah. So there's a couple of systems in there that do that. Does that kind of go over, or questions on kind of how we do that and why we do it the way we do it? It's a little bit of a different paradigm. That's why we don't really call it deduplication, because it's not the same as what everyone else considers it.
And there's no compression stage, just the.
So I would argue when I'm calculating data, I'm compressing it. But it's not a compression that's traditional. That's why we also don't call it compression, right? I'm not running an LZ compression.
Right. So
Yeah.
if I'm storing, a database with fixed length fields, that data's not going to reduce.
That's correct.
Okay.
It might through the deduplication functionality, but not,
But that
not
kind of
through
data
phase
rarely
one.
does that way.
Yeah, you got it.
Yeah.
Right. That question, when we start talking about deduplication and what we do there, that almost always brings up a follow-on, and I'll just jump into it here quickly for you. When some customers want us to be pushing data out kind of the back of our system into a cloud as a persistent backup, if you will.
Mm-hmm.
Now that brings in this whole question, okay, now you're deduplicated, you're compressed. If you're compressing all of our phase data reductions, what do you want on the cloud? Do you want our metadata where we understand so we can pull it back? Or do you want it rehydrated, is the term I like to use? You want me to unduplicate it, push it all back out there flat? You asked earlier about our SAS and our SAS layer. It's thin provisioned. Do you want me to reconsolidate, put it linear, back out on the cloud? Or do you want me to allow my metadata to be out on the cloud? That again for us as a store has characteristics, and we can associate those characteristics and say, you want it deduplicated, you want it duplicated, what type of store is this?
Yeah.
And we can adjust and time
Truth is, I don't want you guys to do that.
it. You want it rehydrated.
I want, because you're a block store, you don't have enough context to be making those decisions. That, I want somebody who knows more about the data than you can.
Because I don't want to. I'm probably
Maybe.
not going to be rehydrating to another NexGen.
Right.
Or I may
Right,
not.
no, I mean, if you're saying cloud, then it's going to some object storage
Yeah,
system.
so Hadoop
and
is
and I want to do, I want to know a lot more about the data to make intelligent decisions about that kind of stuff
Right.
than you guys can as a block store.
And for us, we're a store, you can tell us how you want it to go out. For us, it's a characteristic of the store. Is this store stored in our metadata format or flat?
If you had a couple of sites where you had one here, and you wanted to back up to the cloud
Like-to-like replication's a whole other thing.
through a cloud, you could do it like that. With that, if you didn't want to rehydrate it in flight, you could just throw the blob into the cloud and then pull it down from the other side.
Let's
Yeah,
look at
but-
it from a cold spare.
Yeah.
If we're pushing to the cloud in our format,
Mhm.
and you have a cold spare in a different data center, this data center goes offline, you power up the cold spare, point it at the cloud, we can start populating everything you need.
It's like an obscure chunk of bits at that point, but
Yeah, but all you can do is, but you have to map onto that object store, and all you can do is map volumes to the object store and take the occupied blocks in some way to map them. And if you know more, if you have a file system and you know what the files are, you can be a lot more intelligent about that and use a lot less space at S3. And since S3 is charging you per gigabyte per month, efficiency becomes the primary driver of, they're paying you for bandwidth in, you're charging you for bandwidth in, they're charging you for bandwidth out, they're charging you to hold that stuff.
Yep.
If I only wanted it there to be there 20 minutes, I'm not going to put it there at all. I'm going to go direct place to place. If I'm going to pay them to store it for years, well, then I want to reduce it, and I'm going to be able to reduce it a lot more intelligently if I know, well, that's a swap file, and I didn't need to send it in the first place. And a block storage system can't know that.
Well, but you're playing exactly to why we have characteristics of our store. There are use cases for all of them, right? And I don't want to tell the customer, this is the only use case you can have.
Yeah.
The customer tells me, I want it up on the cloud in NexGen
No,
format.
right. You as a vendor have to occasionally go, oh, Mr. Customer, you want that? It wouldn't be hard for me to do. It would be stupid for you. It wouldn't be hard for me. Sure, I'll do that. That your position as a vendor has to be to do, to not look at the advisability, but of the difficulty.
Yeah.
But from the vendor's standpoint, it can be hard to tell from that would be stupid to that's something I hadn't thought of before. Because there's a lot of stuff that probably 5-10 years ago you'd say that would be stupid. Why would you ever put Flash on the server?
No, and that's
Today
yeah,
it's like
right.
I hadn't thought of that before
Right.
5 years ago or 10 years ago
Right.
or whatever. So
So it's
Yeah,
part of our
it's
store.
better to-
functionality.
But this
Plan in advance and have that
begs
flexibility.
the bigger question: why did you decide to do block storage? That why not do a file system too, have the additional context
Right.
available, fill multiple,
We were having that
broad-
discussion
Yeah.
this morning.
We talk about it all the time, and even when we talked about it in the early days, we talked about it and said, well, we can always do it later if we want. If you do a file-based, it's kind of hard to go back to block.
Oh, yeah, no,
Just
you
files
gotta,
go to
You
block.
can, but you lose lots of performance.
Right.
You can go either way, but it's easier to tack the file system on if you need it.
Exactly right.
And, you know, a lot of people I talk to, a lot of people I work with, they're moving a lot more toward object store rather than file store. And they get confused when I say, well, I need a file system today. You know, 2 years from now, maybe not.
Yeah.
But today, I need a file store. I need to be able to read the files with Unix commands and treat them as Unix files. So
And
I
maybe
think that
the,
direction makes
maybe the
sense.
Hadoop object has a NexGen QoS policy in it, so it tells the block system, I need this, for these data chunks, I need this policy.
Mhm.
I want it stored on this policy on the block.
right, or, you know, you can start saying, well, look, you know, it's a .db file, and therefore it's random access, and it's a .log, and it's there,
Yep.
you know, there's a lot of context available to you there.
Yeah.
That's
You
actually
know,
taking a little bit more.
I don't completely buy the implementing block by having a volume be a file in a file system adds so much overhead that you have to be afraid of it.
Well, if it's 100% transparent, then definitely not, but that's never gonna happen.
No, but I mean, but if you look at, you know, NetApp,
Mm-hmm.
iSCSI on NetApp isn't so much slower because each iSCSI volume is a file in waffle.
Right, but
Then
that's a
it's-
single block, effectively.
Right. So, you know, you can say, I'm gonna build a file system, then I'm gonna put layer block on top of it by making a block volume a file within the file system. If you designed the file system knowing you're going to do that,
Yes, exactly.
the overhead for that is acceptable. You know, yes, there's overhead, but, you know, at some point you just gotta go, yeah, 3% scarce.
Yeah. Yeah. And for us, we took the approach of block is kind of the bottom of everything,
Right.
drives our block. Okay, let's stick there and come up.
Right.
And doing that, to your point though, when or if we decide to do a file system front end for us, we'll be storing it in block internally to us.
Well, I mean, you always end up at block,
Yeah.
you know.
Right.
The question is.
Lowest common
translation.
denominator, so
Yeah.
let's start there and build up.
Well, it's a block's an object.
Yeah. We have lots of those discussions. So that's kind of the phased data reductions. That kind of makes sense. Did I cover the topics you wanted me to cover and give you the information on that? So we kind of got
We're
a.
not having a discussion now?
I know I'm behind. I
No,
wasn't paying
so far it's
attention.
not been a discussion. I felt like I've been on the grill. My turn to turn up the heat.
Then we're doing a good job, all right.
Okay, go ahead.
Yeah, the Twitter feed went quiet, so that's probably a good sign.
Oh, okay. No, actually, it's kind of an open discussion for any of us. So if you guys have any questions on what we've kind of talked about, or
Since we got a little time, and I'll let you guys think of questions. Oh, go ahead.
So, the SBB systems that I've looked at had multiple 10 gig Ethernets,
correct,
canister to canister.
correct.
Is that what you guys are doing?
That's what we use today.
With the RDMA?
Yeah, correct.
Okay.
There's going to be new technologies in that realm.
Well, duh!
I see. Where's that line? Can I cross it?
Oh no, I talked to one other vendor who was, you know, no, we hate that. We're actually, you know, doing that communications over the SAS bus. It's like,
Yeah. Ooh, ouch. No.
yeah, exactly.
Yeah. No. We use SAS bus for what it's useful for, pushing data to drives.
Okay, one more quick topic, let you guys think of any more questions that we didn't hit, is this concept of quality of service and a hybrid. So what you see up here is somewhat representative of what's going on in our system. Now I've added a couple tiers that aren't necessarily reflected in our system today, but say you have a volume with those 7 blocks. Those 7 blocks can exist on one or more of the tiers in our system or the caches in our system at any given time. And so depending on how data is laid out in the system at any point in time, you're going to get a certain performance characteristic of that volume. So say on Monday, you're running 2,000 IOPS on your SQL logs. A bunch of stuff changes in the system. Data is being stored on other tiers and in different caching, in different caches. So now on Tuesday, you have a data layout that looks different. And this is standard stuff that happens in any system that's doing caching and or tiering. But now because the data layout is different, you have a different performance characteristic. So this is a fundamental problem of a hybrid architecture. If you have multiple tiers and multiple types of caching with no way to control where data is going to land, that makes performance extremely unpredictable from a volume standpoint. It can change day to day to day. And this is exactly why we've designed quality of service into the system. It's easy to position quality of service. We always talk about the benefits to the end user, but I'd even challenge that statement to say, it's even stronger than that. Quality of service enables a hybrid design. Without quality of service, you get this unpredictable performance characteristic that you never had on a system that only had one tier, because you can only go one speed. So now you've made the predictable performance problem worse in a hybrid SAN. So quality of service for us is a way to basically survive as a hybrid and meet the requirements that have already been there. A hybrid system without quality of service, in a world where you're trying to manage performance, it exacerbates that problem and makes it worse. So yeah, we position quality of service as a feature benefit, but I also look at it as hybrid doesn't make a whole lot of sense unless you can control this, because or some of the situations occur where non-critical apps are going to consume your highest performance tier, or data from your critical apps are going to get pushed down to other tiers because of what's going on in the system, and you don't have any control over that. So the ability to manage that with quality of service is the thing that really enables a hybrid architecture. That was the last point, I think.
What did you say to me last night about 100% solid state? QoS on 100% solid state? That's a good topic for debate.
Yes. So and it kind of goes into this paradigm as well. What we're trying to do is store blocks that don't need performance on less expensive media. If you have just one tier or basically one set of performance, the only thing you can do is slow it down. You can't speed it up because it's one thing. So putting a quality of service on a single tier architecture just means that quality of service is just going to slow the other things down so other things can go. And in the solid state world, when you're buying or purchasing solid state for performance, having software that actually slows it down, you start getting into conflicts there in the value prop. What you really want to do is...
Well, it's the same QoS versus bandwidth arguments that we have in the network world. That, voice over IP came out, and everybody said, you absolutely have to implement QoS for voice over IP to work, because voice over IP was going to work on a 10 megabit per second Ethernet link, and it took 1 megabit per second to run voice, and you had to manage that bandwidth.
Yeah.
By the time we actually were buying voice over IP PBXs, we were running 100 megabit per second Ethernet. And it turned out we didn't need QoS because bandwidth trumped QoS. If you're trying to manage a resource you have in abundance, you don't have to manage. You don't have to ration.
That's exactly right. Yeah.
But clearly you're taking a small shot at SolidFire. And they're and they're doing QoS on an all solid-state system for a market whose bandwidth demands are so much greater that even though they've got a lot, it's still a limited resource. In the market you're selling into, the solid state has there's so much performance available from the solid state layer that you just have to manage what goes to solid state and what goes to disk. In the market they're going after, the demands are so much greater that the solid state performance becomes a constrained resource and again needs to get managed.
It really comes down to who are you serving. We're really about trying to get to the absolute most affordable solution and squeeze every possible thing that we can out of. That's a very different model than I need massive performance because that's not our customer. So that that's really what it comes down to, the difference in approaches. But
Although, I'm convinced that the next frontier for storage is QoS. That across the board, we've moved from managing storage performance by allocating resources to workloads. But that model broke down for several reasons. Thin provisioning broke that model down. Multi-tenancy broke that model down.
Yep.
Solid state broke that model down because the resources were too expensive to dedicate individually to single workloads. So now we're taking all of our workloads and we're combining them together on shared resources. And we need to have some way
to sort it out,
to decide who gets those resources that are not in abundance.
Yeah.
And frankly, this you guys are leading the pack, but this is the next big thing.
It is.
Yeah.
It's clearly believe that as well.
It's a resource. We just haven't managed the resource as a storage industry. Performance has been a big pool. But and the key thing with all of this, we're just saying to really implement hybrids right. Quality of service is a big requirement because you're facing performance challenges in these virtualized environments. Hybrid makes it worse unless you have something like this. So it's not only a customer benefit, but we see it as a key enabling technology of the architecture and approach as well. I think that's...
So you guys, you have customers, right?
Yeah.
When a customer buys the second box, why do they do that? What do they tell you? I'm assuming you have customers that have bought a second box.
Yeah, it's
Well, it depends. Some customers buy a second box for the same data center. Some buy a second box for remote replication in another data center. It depends on what it is.
So when they buy one for the same data center, what is it they say?
Well, they say, okay, the resources of this system can scale to X number of buyouts and X amount of capacity. We need more than that. Or we want this domain over here separate from this domain, and this is this domain storage, and this is this domain storage.
It gets to a little bit of the more advanced user where they're kind of getting into the multi-tenancy concepts, where there are different budgets. When you get into that kind of a customer, it's a budget over here in finance and a budget over here in engineering. And you start getting into the multiple systems and that.
They like what you've done, right? I'm just curious, because I've always gotten the very best marketing messages from customers.
Yeah.
Right?
Well,
So-
I'll give you an example. We had one customer that was building out IT pods, right? And a pod included a couple of blade servers, a switch, and a storage system. And they would deploy these pods and put a workload on that pod. And then they would buy another one of our systems, build another pod. Now you could argue, well, theoretically, you guys could do all three of those pods off one system, but that's not how they organize their infrastructure. But our one system is very capable of handling most mid-range customers, multiple applications in a mid-range customer environment. And so a lot of guys just buy one system. Now, two systems is typically required for remote redundancy in case you get a flood in this data center, you want to copy your data somewhere else. That's probably the primary reason people buy more than one system.
Us as a vendor can advise them, but they have their own use cases and their own models they need to do.
Well, I'm just, curious. Howard was saying, hey, how important is QoS, right, when you've got an abundant resource. And so I'm just curious, are they coming back and going, hey, this QoS stuff really works? Or are they saying, hey, it's running fast enough, so we're just we're gonna buy it, and it's cheap enough, we're gonna buy another one?
Yeah, it's a really good point. We've learned a lot along those fronts. When we came out of stealth, we wanted to lead with quality of service because that's what all the IP is based around. So we really wanted to make a big splash. And what we found was just saying, storage quality of service, most customers look at you and say, yeah, I don't need that.
Right.
And then you have to have a conversation to say, well, you can run backups in the middle of the day now, you can run VDI along with your SQ. You have to go through that conversation. And then it's like, oh yes, I can use that. But that's hard when you're trying to get awareness as a new company. And so what we found is there's a lot of confusion around solid state. A lot of people are looking at solid state. So what we find is people are typically interested in us up front because of solid state in our system. We've got a great relationship with Fusion.io. When they run into a deal where they need, they call it shared Fusion, they bring us in. That's one example of it. Just the whole PCIe discussion has helped us a lot. So initially we'll get in the door because we have PCIe, and then when we sit down with the customer and ask what's going on, and then we apply the QoS concepts, that's what wins the deal for us at that point. It doesn't win it for us up front. It's the capability that they've never had before. They can see that they can now do this. And it's a warm fuzzy to know that, okay, you guys are going to guarantee that I can get a certain level of performance with this solid state investment. That's what I want. I want to know what I'm going to get from purchasing solid state. And I think it's more about that than, okay, I'm achieving exactly 5,000 IOPS. It's more of a, I feel good because I'm going to spend money on solid state, and there's something there to ensure that I'm going to be happy.
Yeah, I think in the mid-market, it's a lot of, and I sleep well at night.
Yes, yeah, right.
That,
I don't get phone calls.
Exactly.
I could buy a NexGen, I could buy a Nimble. They probably both provide about the same level of performance.
Well, actually
But-
not.
Keep going, Howard.
Well, let's not go there now.
Yeah.
But if I buy the one that's got QoS, then if I turned out to, we all know that in this market, you guess a lot of the time.
Yep.
Right.
You just go, how much do I need? I don't really know. And what happens if I guess wrong? And so I used, when I was a consultant and tape backup was the way you backed everything up, I bought the quantum tape libraries where if you bought the wrong size, you could just stack them together. Because if I guessed wrong, I could just buy another unit to stack them on.
And you
Yep.
can still sleep well.
And if I buy the guy who's got, and if I think either one of both of these are about the right size, and with this one, I can make sure that the guy who decided to back up his laptop at 2 o'clock in the afternoon while payroll was running won't slow down payroll. And with that one, I'm not so sure. Then that's a good reason to buy this one.
Yep.
We get to more sophisticated cases.
That's exactly right.
But there's a certain amount of, I don't know if I need it, but I'll sleep better if I have it, that I think it's appealing for me.
And it's exactly why, you look at LeftHand and EqualLogic, their business model of packaging up all of the software features with those iSCSI SANs. A lot of it was the same. You'd go do investigations. How many of my install base is using replication? It would be a small percentage. But the reason that they bought it and they needed replication was because they didn't necessarily know what they were going to do in the future, and they wanted to know it was there as a fallback mechanism. And that's why that model of putting everything together worked. And like I said, it's the same market. It's just all of these guys have grown up and their infrastructure's grown up. The problems have shifted a little bit. Same mentality though.
Yeah, that was that. I bought EqualLogic back when it was still EqualLogic, and that was one of the reasons I did it.
Yeah.
Because the software.
Yeah, it could, because it's really embarrassing to go back to management and go, we need this add-on.
Yeah.
Let me tell you, the toughest I have ever been on a sales guy is the NetApp guy who didn't tell me, multipathing, it's another $200 per server. Right? We spent $400,000 and they're coming back going, oh yeah, it's another $600. It's like, you must be kidding.
Yeah.
It's all in the fine print.
Yeah.
Yeah, well, no, it's just like, okay, this is de minimis. You're giving this to me. If you don't give this to me, I will personally rip off your head and do strange things to this stuff.
Wow.
Did you really have to go there?
Please do not define strange things.
That image, it's going to take a while to get rid of that image.
That was the toned down version.
Do you
We
guys
might
have
wanna put the
any
live feed.
slides of puppies
After that comment, I think
We're
we'll
gonna
wait.
end this on a note of dead puppies.
No, not dead.
No, I wouldn't kill your puppy. I'm not an animal.
Are you a vegetable or a mineral? Okay.
But certainly the all-in software model, you know, customers love that. You know,
Yeah.
why everybody doesn't do that. I think even NetApp today is bundling everything in a bundle. And,
Well, they've started going,
Yeah.
you know, they've gone from, you know, we have 7,000 line items to we have 16 choices. You know, but I mean, semantic was the
but
worst.
they will try to nickel and dime you any way they can, for sure. Yeah, the customers don't like that. And it's hard to budget for every little feature that you think you might need, and there's inevitably a feature that you need that you haven't thought of, right? Yeah, you don't want to go back to the boss and ask for more.
Not in the same budget year,